You're once again welcome to our channel where mathematical problems are made easy and simple for students understanding. Today too, let's see what mathematics has for us and how we're gonna help you understand the concept one after the other. We are still looking at algebra, and specifically we are diving into simplifying algebraic expressions which involves multiplication and division. So as you can see it here, we have some expressions with which multiplication and division is playing some major important or key points in there. Very good. So here, as we did explaining what we meant by algebraic expression in our previous videos, this time around we will not dive into that, but we are going to dive into how to multiply algebraic expressions. I would mean. Now have it in mind that adding and subtracting algebraic expressions is quite different from multiplying algebraic expressions. I believe you are with me. Very good. So here, whether the terms are like or unlike, we can multiply. So take note of these things. Very good. So before I will start with you through the process journey or through the journey for you to get a concept. I will encourage each and everyone who is on this platform to subscribe and you share the channel or you share the video among your friends so that them too they will find this helpful. Okay, very good. So let's start with a journey and let's see how to go about it. Very good. So as I said, adding and subtracting algebraic expressions is quite different. I get it. Adding and subtracting algebraic expression is quite different from multiplying algebraic expressions or multiplying algebraic things. Very good. So let's take a look at this so that you understand what I'm trying to say. Now, assuming we have 4p plus 8p squared. Under addition of algebraic expression, we cannot add this. That we will say the answer is 12. No, we cannot add this. Why? Because they are not what? Like terms. In the same manner, if we are asked to solve this, okay, we cannot subtract this from that. Why? Because they are not what? Like terms. Why are they not like terms? Because looking at the quantity p, this one is p, 4p, this one is 8p squared, meaning this is different from this. I get it. So now the question is, what about when they are multiplying? So if they are multiplying 4p times 8p squared, if they are multiplying, we can multiply. We can do what? Multiply it. Please, I believe you are following. Very good. Now, if it is dividing 2, we can divide. Whether they are like terms or not, or they aren't, we can still divide. But addition and subtraction is quite different from multiplication and division. Please, are you with me? Addition and subtraction goes with what? Like terms, and multiplication and division does not go for like terms and unlike terms. It does multiplies it whether being like term or unlike terms. Very good. Thank you for your understanding. Now let's proceed with how to solve question number 1. All right. So solving question number 1, I have 4p multiplying or in product terms with 8p squared. Now solving this, we don't consider whether they are like terms or unlike terms. We just move ahead with the principle or the rules, then we multiply as usual. So to make the problem easy for you, what I am going to do is I'm going to split the numbers aside and the variables to aside and multiply them. I would make very good. So this I'm going to go about it. I have 4 multiplying 8. I'll put it in the brackets. Now open another bracket. P multiplying P1 squared. Now have it in mind that what I have here means this whole thing is multiplying this, and I've not changed anything. I would make the power of the P here is 1. So if I to multiply 4 times 8 gives me what? 32. will still have it in a bracket. Then I have p power 1 multiplying p power 2. Have it in mind, in one of the laws of indices, it says when you are multiplying two bases and the bases are the same, what do we do to the powers? You just add. Now, having base p and base p, the bases are the same. It's like you have 2 power 1 multiplying 2 power 2. According to the laws of indices, you maintain one of the bases, and because it is multiplying, you add the powers. So here becomes 1 plus 2. So I'm going to get 2 power 3. So this then becomes my final answer. Same applies to this. The base is what? P. We add the powers, which is 1 plus 2. Where we are going to get what? 3. I believe you are following. Very good. So here I'm going to get 32 in the bracket p power 3. Now multiply through. I'm going to get 32 p cube. So this becomes my answer. So 32 p cube. Very good. Let's continue with question number 2. I believe you understand the process. It's not anything difficult. You move the numbers aside, then the variables that are involved also aside, then you multiply. I believe it is clear. Very good. So number 2, I have negative 2a multiplying 4c multiplying 5b. Are you with me? So I said we group the numbers aside and the variables to aside and multiply. So here, let's continue with the process. I have negative 2 multiplying 4 multiplying 5. In the brackets, I open another bracket, the a will come, multiplying the c, multiplying the b. Okay, so here I'll multiply through 2 by 4, negative 2 by positive 4. I'm going to get negative 8 multiplying 5. And here, in one of the laws of indices, we see when we are multiplying and the powers are the same with different bases, you just multiply straightforward. Likewise, if you have 2 times 3, you can easily multiply this to get what 6 because the powers are what? The same. Are you with me? So here too, because the power here is 1, the power here is 1, the power here is 1. If I can easily multiply it straightforward. Now I'm going to get what? A, C, B. Okay? Very good. So algebraically, let's arrange it well. But before that, let's multiply here first. Then we are going to get what? Negative 14 in the brackets. In alphabetical order, I'm going to get what? A, B, what? C. So my final answer becomes negative 14 A, B, C. Okay, now here you don't get a squared, nothing. Because here is A, here is C, here is B. They are not like terms. Assuming here is supposed to be, let's say A, we would have gotten, here would have been A squared B. Okay, here would have been A squared B. If here, assuming here is A, because they are like terms and I have to, if they are like terms, here become power 1, and I'm going to get 1 plus 1, where A becomes A squared. I get it, me? But over there, because here is C, that is why we had ACB. Please, I believe you are following. Very good. So that is what we are getting. That's what we are getting. So our answer for question number 1 is this, and our answer for question number 2 becomes that. Right. So quickly we dive into question number 3. So as I said it earlier, when you are asked to solve problems like this, that is algebraic expression involving multiplication, you just take the whole numbers or the numbers which are in front of the variables, we call them coefficient. You take it, then you multiply, as I have done here, so that everything will be in a smooth pace. Very good. If you have any question concerning the procedure, please you can direct the question to us through the comment section, and we will make sure that we'll help you understand everything that involves. Very good. So let's continue with life. I have question 3. So here to multiplying that, I'll group the numbers aside. So I have 5 times 4. Then here you could see that I have x here, so I can group x multiplying x power 4. Then I can also group y squared multiplying y power 3. So here I have 20. Here the power here is 1. So because it is multiplying, I'll add the power. So I'll have x power 1 plus 4. Then y power 2 plus 3. I believe you are following. Very good. So here we are getting 20 in a bracket x power 5, because 1 plus 4 gives us 5. In a bracket y power 2 plus 3 gives us what? 5. We are getting 20 x power 5 y power 5. This then becomes our final answer. I believe you are good with that. Very good. Thank you very much. So we are through with the multiplication. Now it's left with us to dive into the division. I believe we are good. Very good. So you remember we said the multiplication, you just take the coefficient, you multiply the variables in the, if they are like terms, make sure you do justice to the addition of the individual exponent, like what we have done here, adding it because it is multiplying. Very good. Now the division also comes in with its own way of solving it. Very good. So let's quickly dive into question number 4. Then we will all see how to solve that. Let me clean this, then we dive into question number 4. Question number 4, I have 16 a power 3 b squared divided 2ab. Now we all know that mathematically, when we have 2 divided by 3, this can be rewritten as 2 over 3. Mathematically, this is the same as this. This is the same as what I have here as this. It's the same thing. Are you with me? Alright. So in the same manner, if I have 2 divided by, let's say 3ab, this can be rewritten as 2 over 3ab. I believe you are following. So this is the same as what I have here. I believe you are following. Very good. So let's see how to solve what we have here. It means that we have a component here divided by this component. So this can be rewritten as 16a squared b squared all over 2ab. I believe you are following. Very good. Likewise, what we have done here. So from here, we can continue with life. So what we are going to do now is we are going to split individual components with respect to its term so that you understand it well. Now let's see something here. Have it in mind that here, for the problem to be easily solved, we can easily do some sort of cancellation because it is dividing, and here I can cancel out. So over here, I can have 2 cancelling this 1 going into 16 8 times. I believe you are following. Very good. And here too, I can cancel the a by the a, the b by the b. So that's the understanding. Very, very simple. So what does it mean here? It means that mathematically, I have 8a squared left, b squared all over 1ab. Now, do you know that this can also be rewritten as 8 multiplying? You see, it is still in product terms. I would mean if I have 2a, it is the same as 2 times what? A. So it's still in product terms. So this can be written as a. We know that a squared is the same as a times what? A. So here can be a times a multiplying b times what? B all over. Please, are you following? Now here b squared is the same as b times what? b, and that's what I have done here. A squared is also the same as a times a, and that's what I have done here. Let's continue with life. So I have over 1 times a times what? B. So that here the a will get rid of this and the b will get rid of that. So let's see what we have left. We have 8 multiplying a multiplying what? B, all over 1 is left with 1. So we continue with life. So here we can easily multiply a times b. We are getting 8ab all over 1. And we said that anything over 1 in terms of math is a term itself. So if we have anything over 1, anything that bears the denominator to be 1 is a term itself. So our answer over here becomes 8ab. I believe you are good with that. Very good. So that is how to go about it when you are diving into problems involving fractions. Problems involving division, which we want to fraction to solve it. Very good. Now let's dive into question number 5. Then, if time will permit us, if time will not permit us, we will give you question number 6 to try your hands on it. Question number 5. Question number 5, I have 21 x power 7 divided by 3x power 4. Remember, this mathematically can also be rewritten as 21x power 7 all over 3x power 4. Are you with me? Very good. So let's continue with the process. So this can also be rewritten as 27 multiplying x power 7 all over 3 times x power 4. Please, this multiplication sign and it's still the same. So the 3 cancels out, 1 goes here, 9. I believe you are following. Very good. So here we have 9 multiplying x power 7 all over 1 times x power 4. Very good. So let's continue with life. So as we did for question number 4, we are going to apply the same concept here. Now we have 9 multiplying, see, x power 2 means x times what? X. So x power 3 means x times what? X. X power 4 means x times x times x times x. 1, 2, 3, 4. 1, 2, 3, 4. So x power 5. You can imagine how many x's are we going to get? X power 6. You can also imagine that. Are you with me? Very good. So here x power 7, x power x multiplying x multiplying x multiplying x. How many times? 7 times. 7 solid times. Are you following? Very good. We want to make sure that the problem becomes what? Easier. Are you getting me? But before that, let's make it simpler here. Have it in mind that assuming here is x power 100, the question is, are we going to write x times x times x till we get x power 100? No. So here, making it simpler, we are going to get 9 multiplying. Remember, we can rewrite this one as x power 4 multiplying x power 3. Okay? All over 1 multiplying x power 4. Remember, this is mathematically, I have no change in it. The x power 7 is the same as x power 4 multiplying x power 3. Why? Because in mathematics, when we have x power 2, it's still the same as x power 1 multiplying x power 1. Okay? Because when you multiply, you are going to get x power 1 plus 1, or you are going to get x power 2, which is the same as what we have here. Are you with me? So I splitted it so that one of the component can get rid of that. In the same manner, when you have x power 5, this can also be written as x power 2 multiplying x power 3, or x power 5 can also be regenerated as x power 4 multiplying x power 1. See, when we add 4 plus 1 gives us what? 5. I believe you are following. Very good. So here we can clearly see that this and this are the same. The powers are the same. So this one will cancel this, leaving behind x multiplying x power 3 all over 1 times. Here is also left with 1. Okay, so it cancels out. Then we are getting 1 there. So I'm going to get 9 times 1 multiplying x power 3. And here that. Are we good? Very good. So here to continue with like we multiply, we are getting 9x power 3 all over 1. And this is the same as, let's write our answer what? 9x power 3. So this then becomes our final answer. This I believe we are good. Very good. Now over here, x power 4 multiplying x power 3. When we are to solve this, we are going to get 4 plus 3. So we are going to get x power 7 because 4 plus 3 gives us what? 4 plus 3 gives us 7. That's why we have this. I believe we are good. Very good. So we end here as our final answer. Let's dive into the latter part of the question, which is question number 6. The question number 6, I have 10x power 6 so mathematically this can also be rewritten as 10x power 6 y power 4 all over 2x power 4 multiplying y squared. So this can also be expressed as 10 multiplying x power 6 multiplying x power 4 all over 2 multiplying x power 4 multiplying y power 2. So we continue at the next section, then after we proceed with life. So we have the continuation here. I remember over here the 2 and the 10 can easily go away. So here 1, here what? 5. You know that 2 goes into itself 1 and goes into 10 what? 5 times. So we continue with life. So here we have 5 left multiplying x power 6. And remember, for us to obtain something here like this, you can rewrite x power 6 as x power 4 multiplying x power 2. Okay? Okay? I believe it is clear. Because here x power 6 can be expressed as x power 4 multiplying x power 2. Because here when you solve it, you are going to get x power 4 plus 2. And 4 plus 2 gives us what? X power 6. Which this is the same as what we have here. So we are going to replace this by x power 6 as we have it here. So here becomes x power 4 multiplying x power 2. I believe it is clear. Very good. In the same manner, y power 4 can be expressed as y power 2 multiplying y power 2. We are doing it so that we are expressing this of the form x power 4. That's why we have x power 4 times, so that this can cancel out over there. So that one too, we have multiplying y power 2, y power 2 all over. So here we have 1 left multiplying x power 4 multiplying y power 2. Please, are you following? Very good. So that here this can get rid of this 1, and here too it can get rid of this by 1. So we are getting 5 by 1, 5 by 1 by x power 2 by y power 2, then by 1 as we have here, all over 1 by 1 by 1. So continuing with life, you realize that we are going to get 5 times 1 is 5 by this. We are going to get x squared y squared all over 1, which our answer then becomes 5x squared y squared. This then becomes our final. Let me write my x well. So we are going to get this as our final answer. I believe you understand the process and everything is in a smooth manner. Thank you very much for staying tuned, and I believe you are blessed by now. As I said this earlier, make sure you subscribe to this channel. If you find this video helpful, please share, like, and comment so that you also hit the notification bell so that you'll be the first person to witness this video or any video that we upload into this channel. Have a great day, and please do not hesitate to share it among your colleagues who also need help like this. Thank you very much for staying tuned. Bye bye.